In modern mapping, a topographic map is a type of map characterized by large-scale detail and quantitative representation of relief, using contour lines but, historically, using a variety of methods. Traditional definitions require a topographic map to show both natural and man-made features. A topographic map is typically published as a map series, made up of two or more map sheets that combine to form the whole map. A contour line is a combination of two line segments that connect but do not intersect. These represent elevation on a topographic map. The Canadian Centre for Topographic Information provides this definition. A topographic map is a detailed and accurate graphic representation of cultural and natural features on the ground. Other authors define topographic maps by contrasting them with another type of map. They are distinguished from smaller-scale chorographic maps that cover large regions, planimetric maps that do not show elevations, and thematic maps that focus on specific topics. However, in the vernacular and day-to-day world, the representation of relief is popularly held to define the genre, such that even small-scale maps showing relief are commonly called topographic. The study or discipline of topography is actually a much broader field of study which takes into account all natural and man-made features of terrain. History. Topographic maps are based on topographical surveys. Performed at large scales, these surveys are called topographical in the old sense of topography, showing a variety of elevations and landforms. This is in contrast to older cadastral surveys, which primarily show property and governmental boundaries. The first multi-sheet topographic map series of an entire country, the Carte Gare copyright Omer copyright Tric de la France, was completed in 1789. The Great Trigonometric Survey of India, started by the East India Company in 1802, then taken over by the British Raj after 1857, was notable as a successful effort on a larger scale and for accurately determining heights of Himalayan peaks from viewpoints over 100 miles distant. Topographic surveys were prepared by the military to assist in planning for battle and for defensive emplacements. As such, elevation information was of vital importance. As they evolved, topographic map series became a national resource in modern nations in planning infrastructure and resource exploitation. In the United States, the national map-making function, which had been shared by both the Army Corps of Engineers and the Department of the Interior, migrated to the newly created United States Geological Survey in 1879, where it has remained since. 1913 saw the beginning of the International Map of the World initiative, endeavoring to map all of Earth's significant land areas at 1 million scale on about 1,000 sheets covering 4 degrees latitude by 6 or more degrees longitude. Excluding boundaries, each sheet was 44 cm high and up to 66 cm wide. Although the project eventually foundered, it left an indexing system that remains in use. By the 1980s, centralized printing of standardized topographic maps began to be eroded by databases of coordinates that could be used on computers by moderately skilled end users to view or print maps with arbitrary contents, coverage and scale. For example, the federal government of the United States Tiger Initiative compiled interlinked databases of federal, state and local political borders and census enumeration areas, and of roadways, railroads, and water features with support for locating street addresses within street segments. Tiger was developed in the 1980s and used in the 1990 and subsequent decennial censuses. Digital elevation models were also compiled, initially from topographic maps and stereographic interpretation of aerial photographs and then from satellite photography and radar data. Since all these were government projects funded with taxes and not classified for national security reasons, the data sets were in the public domain and freely usable without fees or licensing. Tiger and DEM data sets greatly facilitated geographic information systems and made the global positioning system much more useful by providing context around locations given by the technology as coordinates. Initial applications were mostly professionalized forms such as innovative surveying instruments and agency-level GIS systems tended by experts. By the mid-1990s, increasingly user-friendly resources such as online mapping in 2 and 3 dimensions, integration of GPS with mobile phones and automotive navigation systems appeared. As of 2011, the future of standardized, centrally printed topographical maps is left somewhat in doubt. Uses. Topographic maps have multiple uses in the present day: any type of geographic planning or large-scale architecture, earth sciences and many other geographic disciplines, mining and other earth-based endeavors, civil engineering and recreational uses such as hiking and orienteering. Conventions. The various features shown on the map are represented by conventional signs or symbols. For example, colors can be used to indicate a classification of roads. These signs are usually explained in the margin of the map, or on a separately published characteristic sheet. Topographic maps are also commonly called contour maps or topo maps. In the United States, where the primary national series is organized by a strict 7.5-minute grid, they are often called topo quads or quadrangles. Topographic maps conventionally show topography, or land contours, by means of contour lines. Contour lines are curves that connect contiguous points of the same altitude. In other words, every point on the marked line of 100 am elevation is 100 am above mean sea level. These maps usually show not only the contours, but also any significant streams or other bodies of water, forest cover, built-up areas or individual buildings, and other features and points of interest. Today, topographic maps are prepared using photogrammetric interpretation of aerial photography, LiDAR and other remote sensing techniques. Older topographic maps were prepared using traditional surveying instruments. Publishers of National Topographic Map Series. Although virtually the entire terrestrial surface of Earth has been mapped at scale 1 million, medium and large-scale mapping has been accomplished intensively in some countries and much less in others. Nevertheless, national mapping programs listed below are only a partial selection. Several commercial vendors supply international topographic map series. Australia. The NMIG of Geoscience Australia is the Australian government's national mapping agency. It provides topographic maps and data to meet the needs of the sustainable development of the nation. The Office of Spatial Data Management provides an online free map service, Map Connect. These topographic maps of scales 1, 250,000 and 100,000 are available in printed form from the sales center. 50,000 and 25,000 maps are produced in conjunction with the Department of Defense. Austria. Austrian Maps is the government agency producing maps of Austria, which are distributed by Bundesamt für Quartiereich und Vermessungswesen in Vienna. The maps are published at scales 1, 25,000, 50,000, 200,000 and 500,000. Maps can also be viewed online. Canada. The Centre for Topographic Information produces topographic maps of Canada at scales of 1, 50,000 and 250,000. They are known as the National Topographic System. A government proposal to discontinue publishing of all hard copy or paper topographic maps in favor of digital-only mapping data was shelved in 2006 after intense public opposition. China. The State Bureau of Surveying and Cartography compiles topographic maps at 1, 25,000 and 50,000 scales. It is reported that these maps are accurate and attractively printed in 7 colors, and that successive editions show progressive improvement in accuracy. These large-scale maps are the basis for maps at smaller scales. Maps at scales 1, 4 million or smaller are exported by Cartographic Publishing House, Beijing, while larger-scale maps are restricted as state secrets, and prohibited from publishing by legislation, all except Hong Kong and Macau. China's topographic maps follow the international system of subdivision with 100,000 maps spanning 30 minutes longitude by 20 minutes latitude. Colombia. The Geographic Institute Augusta N. Catazzi is the government entity responsible for producing and distributing topographic maps of Colombia in 500,000 and 100,000 scales. These and several other geographic information services can be accessed using the Instituto Geográfico Agustín Catazzi website in Spanish. Denmark. The National Survey and Cadastre of Denmark is responsible for producing topographic and nautical geodata of Denmark, Greenland and the Faroe Islands. Finland. The National Land Survey of Finland produces the topographic database and publishes topographic maps of Finland at 1, 25,000 and 1, 50,000. In addition, topographic maps can be viewed by using a free map service map site. France. The Institut Cartographique National produces topographic maps of France at 1, 25,000 and 1, 50,000. In addition, topographic maps are freely accessible online, through the Cartographic Portal website. Germany. In principle, each federal state is in charge of producing the official topographic maps. In fact, the maps between 1, 5,000 and 1, 100,000 are produced and published by the land surveying offices of each federal state, the maps between 1, 200,000 and 1 million by a federal officer. The Bundesamt für Cartography under der Currency in Frankfurt am Main. Greece. Topographic maps for general use are available at 1, 50,000 and 100,000 from the Hellenic Military Geographical Service. They use a national projection system called EGSA 87, which is a transverse mercatorial projection mapping Greece in one zone. A few areas are also available at 1, 25,000. Some private firms sell topographic maps of national parks based on HMGS topography. Hong Kong. The Department of Lands is the government agency responsible for surveying and publishing topographic maps of Hong Kong. Commonly used maps such as the HM20C series are reviewed and updated every year or two. Very large-scale topographic maps are also available to public for various uses. India. The Survey of India is responsible for all topographic control, surveys and mapping of India. Japan. The Geographical Survey Institute of Japan is responsible for base mapping of Japan. Standard map scales are 1, 25,000, 1, 50,000, 1, 200,000 and 500,000. Nepal. From 1992 to 2002 a definitive series of large-scale topographic maps were surveyed and published through a joint project by Government of Nepal Survey Department and Finland's Ministry for Foreign Affairs contracting through the FinMap consulting firm. Japan International Cooperation Agency substituted for FinMap in Lumbini Zone. Topographic sheets at 1, 25,000 scale covering 7.5 minutes latitude and longitude map the densely populated tri- and middle mountain regions. Less populated high mountain regions are on 15-minute sheets at 1, 50,000. JPG scans can be downloaded. Netherlands. The Land Registry Cadastre collects, processes and provides topographical information of the entire Dutch territory. The history of the Land Registry goes back to the year 1815, that year was commissioned to create a large map, known as Map of Kruyenhof. Around 1836 they began printing the topographic map on a scale of 1, 50,000, followed in 1865 by the topographic map on a scale of 1, 25,000. In 1951 began the start of production of the topographic map on a scale of 1, 10,000. From various reorganizations arose in 1932 the Topographisch Dienst as National Mapping Agency of the Netherlands, since January 2004 housed within the Land Registry Cadastre. New Zealand. Land Information New Zealand is the government agency responsible for providing up-to-date topographic mapping. LIN's topographic maps cover all of New Zealand, offshore islands, some Pacific islands and the Ross Sea region. The standard issue NZTOPO map series was published September 2009 at 1, 50,000, and 250,000. Vector data from the New Zealand Topographic Database is also available. Pakistan. The responsibility for topographic mapping and aerial photography lies with the Surveyor General of Pakistan, SGP. Established in 1947, the Survey of Pakistan is based in Rawalpindi with a number of regional offices distributed at urban centres throughout Pakistan. SGP is a civil organisation which, for security reasons, is headed by a Surveyor General and works under the strict control of Army General Headquarters. Colonel C.A.K. Innes Wilson, a Royal Engineers officer who joined the Survey of India which mapped the subcontinent, was the first Surveyor General of Pakistan. All departments which require topographic maps make their request to SGP, and many are permanently registered with it for mapping and aerial photographs procurement. The SOP performs these functions under the auspices of the Ministry of Defense. Organizationally, the SOP is overseen by the Surveyor General, who is a direct military appointee and a senior uniformed officer. The SG reports directly to the Secretary of Defense. Under the SG are two deputy SCA-1 registered trademark S who manage the operational departments of the agency, and a senior technical advisor. These departments are divided into regional directorates for topographic mapping, including the Northern Region centered in Peshawar, Eastern Region, Western Region, and finally, the Southern Region in Karachi. Responsibility for field surveys and the maintenance update of topographic maps are subdivided according to these geographic areas. Portugal, the Army's Geographical Institute, Instituto Geográfico do Ixa Copyright RCITO, 1, produces 1.25,000, 500,000 maps for public sale, as well as lots of geographical services. Russia, detailed, accurate topographic maps have long been a military priority. They are currently produced by the Military Topographic Service of Armed Forces of the Russian Federation. Military topographic mapping departments held other titles in the Russian Empire since 1793 and in the Soviet Union, where these maps also came to be used for internal control and economic development. When Germany invaded in 1941, detailed maps from the USSR's western borders to the Volga River became an urgent task, accomplished in less than 1 year. After the war years, the entire Soviet Union was mapped at scales down to 1/25,000 euro, even 1/10,000 for the agriculturally productive fraction. The rest of the world except Antarctica is believed to have been mapped at scales down to 1/200,000, with regions of special interest down to 1/50,000 and many urban areas to 1/10,000. In all, there may have been over 1 million map sheets of high quality and detail. Soviet maps were also notable for their consistent global indexing system. These advantages held for Soviet military maps of other countries, although there were some errors due to faulty intelligence. Soviet maps for domestic civilian purposes were often of lower quality. From 1919 to 1967 they were produced by Head Geodesic Administration, then by Chief Administration of Geodesy and Cartography. Now civilian maps are produced by the Federal Agency for Geodesy and Cartography. Soviet military maps were state secrets. After the 1991 breakup of the Soviet Union, many maps leaked into the public domain and are available for download. Map scales 100.000-1, 500.000 can be viewed online. Spain, the Instituto Geográfico Nacional is responsible for the official topographic maps. It does use 6 scales that cover all the Spanish territory: 1/25,000, 1/50,000, 1/200,000, 1/500,000, 1 million and 1/2 million. The most common scale is the first one, which utilizes the UTM system. South Africa, the Chief Directorate, National Geospatial Information, produces 3 topographic map series, each covering the whole country, at scales 150,000, 1/250,000, and 1/500,000. Switzerland, Sistapo produces topographic maps of Switzerland at 7 different scales. Taiwan, topographic maps for Taiwan had long been kept as confidential information due to security concerns. It has only been recently made available to public from the National Land Surveying and Mapping Center, the government agency responsible for surveying and publishing various maps. Topographic maps of up to 1/25,000 is now available in digital and printed format. United Kingdom, the Ordnance Survey produces topographic map series covering the United Kingdom at 1/25,000 and 1/50,000 scales. The 1/25,000 scale is known as the Explorer Series, and include an OL sub-series for areas of special interest to hikers and walkers. It replaced the Pathfinder series, which was less colorful and covered a smaller area on each map. The 50,000 scale is known as the Land Ranger, and carries a distinctive pink cover. More detailed mapping as fine as 1/10,000 cover some parts of the country. The 125K and 150K metric scales are easily coordinated with standard Roma scales on currently available compasses and plotting tools. The Ordnance Survey maintains a mapping database from which they can print specialist maps at virtually any scale. Ordnance Survey National Grid divides the UK into cells 500 km and 100 km square on a transverse Mercator grid aligned true north-south along the 2° W meridian. OS map products are based on this grid. United States. The United States Geological Survey, a civilian federal agency, produces several national series of topographic maps which vary in scale and extent, with some wide gaps in coverage, notably the complete absence of 1/50,000 scale topographic maps or their equivalent. The largest and best-known topographic series is the 7.5-minute or 1/24,000 quadrangle. This scale is unique to the United States, where nearly every other developed nation has introduced a metric 1/25,000 or 1/50,000 large-scale topo map. The USGS also publishes 1/100,000 maps covering 30 minutes latitude by 1 degree longitude, 1/250,000 covering 1 by 2 degrees, and state maps at 1/500,000 with California, Michigan and Montana needing 2 sheets while Texas has 4. Alaska is mapped on a single sheet, at scales ranging from 1,584,000 to 1/12 million. Recent USGS Digital US Topo 1/24,000 topo maps based on the national map omit several important geographic details that were featured in the original USGS Topographic Map series. Examples of omitted details and features include power transmission lines, telephone lines, railroads, recreational trails, pipelines, survey marks, and buildings. For many of these feature classes, the USGS is working with other agencies to develop data or adapt existing data on missing details that will be included in the national map and to US Topo. In other areas, USGS digital map revisions may omit geographic features such as ruins, mine locations, springs, wells, and even trails in an effort to protect natural resources and the public at large, or because such features are not present in any public domain database. OpenStreetMap, based on the world map data of the OpenStreetMap project, and the Shuttle Radar Topography mission data, alternative topographic maps are available. See also: Aeronautical chart, bathymetric chart, nautical chart, list of national mapping agencies, hypsometric tints, topographic profile, raised relief map, stereoplotter, international map of the world, references. External links: USGS topographic maps are downloadable as PDF files from a searchable map or by a search if the map name is known. Topographic symbols: a Euro-US military guide to topographic maps, how a topographic map is manufactured, history, and other information. 4 maps are topographic outdoor maps with elevation lines and hill shading.